Hi, everyone, and welcome to today's webinar, 4 Big Reasons Applications Fail to Meet Customer Expectations, with Apposite Technologies and Scott Moore Consulting. Thank you for joining us. To begin our presentation, we'll introduce our experts, then dive into the 4 big reasons applications fail to meet customer expectations, followed by some testing best practices and a demonstration of use cases. Our first speaker today is Scott Moore. Welcome, Scott.
Thanks, Rebecca. It's good to be here with you, and thanks everybody for attending. I have been doing performance testing and engineering about 22 years now. I've used a lot of tools and techniques and learned process. I share it generally online, so I guess I'm considered a performance engineering evangelist. So I've just recently partnered with Apposite, and I'm really excited about that. And I'm glad that we're able to share with you these reasons why some of these applications are still failing, even though you might be doing testing in production. So thank you for having me.
You're welcome, Scott. And our next speaker is from Apposite, Cade Nelson.
Hi, everyone. My name is Cade Nelson. I'm a systems integration engineer at Apposite. I have been working in the WAN industry for over 20 years. In fact, I was employee number 56 at Earthlink Network. For those of you who've been around that long, I started out as a dial-up modem troubleshooter, and I slowly worked and clawed my way up to being a network engineer. Again, I work for Apposite. A little bit about who we are. We are the market leader in network emulation. We've been around for about 15 years and have over 3,000 customers worldwide. Some of those customers are listed here on the right. So what Apposite really does is allow anyone who has a product that needs to run over a wide area network to test, deploy, and quality assure. And you can do this before you push it out to the real world. We can build complex networks with real world characteristics, deliver accurate and cost-effective performance tests. You can do your tests and deploy confidently, measure your performance, and understand any limitations you may have, and you can set reasonable SLAs. And also you can identify any design flaws or performance bottlenecks. So 4 big reasons applications fail to meet customer expectations.
Well, let's take a look at the first one. Recently, I just went out and Googled how much of the internet traffic is mobile. And it's now at 53%, last statistics that I saw. And I've been watching this grow probably since Black Friday 2017, I think is when we actually breached the 50% mark for sales and transactions that happen over the holiday season in the US. So that got me thinking, you know, how much of this overall traffic continues to increase through mobile devices? And now that we've reached that point, I have tested with LAN emulation in the past for various reasons, but now I think it's more important than ever. And that's one of the reasons why it triggered me to want to partner with Apposite, because we have users now accessing the most important applications, sales transactions, financial applications, applications on their phone or their mobile devices on the dirtiest networks that we have. And so that needs to be addressed in the testing lab, because if you don't, you're probably going to have some performance issues slip through the cracks, and we'll demonstrate that today. One of the examples here is about Costco. Last Black Friday, this past one, they had a very expensive lesson. I've seen figures from 11 million to 14 million that they learned a hard lesson being down the primary hours of Black Friday, losing lots of money due to the unexpected number of mobile users accessing their application. So these mobile connections, they have sometimes poor reception. Sometimes it's bad Wi-Fi. It's a bad wireless router in your house. The user is traveling and going in and out of these connections, and the user it's a shared network. So this is something that is important, and if you don't address the mobile user factor, your application can fail to meet what your users expect. Right, Cade?
Absolutely. So if we go to the next slide here, here's a quick little diagram of some homepage tests. So if you look at these two performance graphs, we can see that in a nice, clean kind of LAN or non-dirty network setting, this homepage can easily handle over 500 users simultaneously without any problems. But we move that same exact homepage over to a network that's a cellular network or a network that emulates cellular connectivity, and the service level objective is not met. And the homepage performance decreases to less than 200 simultaneous users. The lesson here is you cannot test without applying real world conditions. There are two things you should know about your network application or your homepage in this example: where you perform best and where your failure point is.
The second reason is about the end user experience. I talk a lot about this on my online show, The Performance Tour. Almost every episode you'll hear me mention it. And it's always about looking at your application from the eyes of the user. And I always ask this question when I have a virtual audience or a real audience, and I always see a lot of head nodding and hands being raised. When was the last time you were at a doctor's or dentist office or somewhere where there's a receptionist, you're checking out of a hotel, you're online on the phone ordering something, and you hear those words, "I'm sorry, our computer systems are slow today. I've got a spinning wheel. I hate this application. I wish it was faster. Can you hang on the line?" You know, I hear that a lot, and most people have experienced that probably recently. And I find it amazing that in 2020, we're still having that conversation. And it's because we have people in IT, and I'm one of them, I'm pointing the finger back at me. We look at things like, well, we have enough bandwidth on the network, or we have a database that's really fast. Our API calls are fast. So everything must be okay. And we're on the cloud, so we obviously have unlimited scalability, right? But we're not experiencing what that receptionist is. So we're not looking at things through their eyes. And I think that's a mistake. So it starts with that. And part of that is just creating reality. And when you don't include LAN emulation, you're not emulating the actual network. You're not doing that full picture. You're not doing that full view that they may experience in, say, a remote office, or maybe they have, you know, still an old DSL line or something crazy that, you know, we wouldn't have in a pristine lab situation. So think about the end user and the times they're using it, when they may be conflicting with others, and think about that when you're actually testing, not when you put it out into the real world. An example that we have that I've seen online, you can search this for yourself, but the Steamboat Authority for Martha's Vineyard, they relaunched their application, but they only tested for the desktop users, and not realizing that when people wanted to know if the ferry was available, they were driving around, and they were probably pretty close to the vicinity in that area, and they didn't really have that great a reception, and they're trying to check, and that caused a problem with the site because they couldn't get to it, or there were either too many of the mobile type users, but for that reason, they weren't thinking about the customer that was actually using their application.
Right. So even if it's not your fault, it's going to be your fault. So what does that mean? It means if the customer's on a bad network or a dirty network, or they don't have great reception, or maybe they're far away and traversing over an ocean or a sea and it's not working great, that customer is still going to experience a bad time using your product. And even though it's a network issue, you're still going to get blamed for it. They're going to say, oh, this site isn't good, or this product isn't good, or this is junk. They will associate the poor performance to your product or your application. And you can't go around and explain to each user how they need to fix their network, or what their network is, that it's their network that's the problem. What you have to do is you have to optimize and tune your app to perform under these imperfect scenarios.
So the third reason that we've listed here is the laws of physics still exist, unfortunately for us, right? If we could manipulate that, maybe we could make all applications successful. but there is going to be network latency. Not necessarily bandwidth is the problem, more so latency. And there are, we've got global, companies that have to even think about, should I go east or west from New York or California to get to Japan or somewhere? And they they have to save on every millisecond of latency they can when they're traversing those packets around the globe. So that's an area that you need to think about, in that you can't make the cable shorter. The length of the cable is the cable, and you still got to go through that, and that still happens. Another thing, I've seen developers, it's not really a problem for a developer to create a web page where the home page is 43 megs in size. That actually happened to a retailer last Black Friday and caused them to go down because of that. That company's actually going through bankruptcy protection as of today. So that's just probably one straw on top of the camel's back that caused this. But this is something that you guys see a lot, right, Cade?
Absolutely. And we always suggest people invest in one of our emulators. We can emulate scenarios where there's multiple paths to the same destination. These developers can develop behaviors to exploit the best available paths. You'll be able to find, hey, 40 some odd megs of a web page is way too large for even a 5G network. So people will can use our WAN emulators to tune things up, and they can make some changes. Some things as simple as moving from UDP, which is very lossy, over to TCP. They can slim down their network conversation. Again, that 40 meg home page is way too big. They could probably get rid of some of the large media files or image files on there and get their response time much better. They can incorporate third-party WAN optimizations or TCP optimizations. And they can just understand and put themselves in the user's position to clean things up.
I always think that the fastest call is the one that you never have to make. So sometimes it's just we're making too many calls when we shouldn't, and maybe sometimes we're sending too much data when we shouldn't.
Absolutely.
And that brings us to the fourth reason, which is 5G really isn't going to save the world. I hear a lot of people telling me, Scott, I'm not worried about things because I know our app's a little fat and I know our app's having some problems now, but when we roll out 5G, it'll be just like the cloud with unlimited scalability. We're going to have unlimited bandwidth to all mobile devices. Everybody's going to get a gig to their phone all the time, and we won't have to worry about all this performance testing stuff. What do you think about that, Cade?
Well, just recently, Forbes did a study and found that the average speed of 5G is around 130 megabits. So everyone who's dreaming that they're going to be getting a full gig, they can keep dreaming. But it's true. 5G can and will see large latencies. It's still going to see jitter. It's still going to see loss. And you're even going to have micro outages as well. So everyone who thinks 5G is going to save us from all of this pain, it's not. You're going to see the same issues you see on any network that has latency, jitter, loss, and outages.
And it's a shared resource, right? So that means that as more people are on it, just like other technologies, the more people that are on it, the more shared resources you have, the more dirty the network's going to be, right?
Exactly.
So let's go back and talk about these four things again, just to refresh our minds. Everybody is going to need to prepare for Black Friday at some point. We talk about retailers and we talk about that shopping, that holiday experience, but think about with the recent pandemic, we have seen that government, federal government, the IRS, state unemployment offices, we've seen that companies have shifted their workforce to home, causing their VPNs to be overloaded. So they've shifted the load and they weren't necessarily prepared. Banks, people checking for those checks to be in their bank account on mobile devices. Financial institutions still weren't ready in some cases. That was their Black Friday. So now more than ever, we need to be doing more performance testing, and we need to do it in a more realistic fashion by using WAN emulation. Also, We need to look through the eyes of the end user. It's not just about setting up the right things in IT, looking at the individual pieces. We need to look at it as a whole, and we also need to compare that to things like real user monitoring, end user monitoring, and making sure we get that last, even at the edge, information if we can. You need to get some type of litmus test between with and without this network latency. So get your best case, but then get your worst case and figure out the difference between the two and see how much of an impact it'll make. And in a moment, you're going to see even just a little bit of a change, a little bit more of a latency can cause, twice the timings to be twice as high, I should say. And also, just like with the cloud, moving to the cloud, people thought, well, we'll just turn on auto scale. We'll monitor it. We can always go scale out if we need to. And then they saw the cloud bill at the end of the month, or then they found out that it wasn't necessarily that it couldn't scale. There was a configuration problem. And as soon as this configuration was, breached in some way, immediately they hit the wall. So we still have these outages that we see. So 5G isn't necessarily going to overcome any kind of poor code or poor infrastructure choices. So you need to consider that in your testing. So know how your application operates under the worst possible conditions, and that's really the goal of load testing. I always get this question in a meeting that says, tell me the difference between load testing my application and stress testing it. I always say, I can stress test your application in about 15 minutes. I'll just throw load at it like a machine gun, and we'll just see the first point of failure. Could be your web server, could be something else. But unless you're prepared to make a change and see if the bottleneck moves further, that may not be as valuable to you. So instead, we look for doing load testing, which is what's going to happen in my Black Friday, my real world nightmare, but could really happen. That's what we want to try to recreate, because then you can actually see how your system is responding and what you're going to need to do if it doesn't go the way that you think. So I think that WAN emulation plays an important part in all of this, especially when we're trying to do realistic load testing.
Great. So why WAN emulation? I think we just explained it out this entire webinar. It's always best for you to identify problems instead of your customers finding those problems for you. And if there's going to be a network problem, the WAN emulation is going to help you identify that. Using one of our devices, one of our WAN emulators, we're going to allow you to mimic real-world networks and topologies, and you can test performance, you can troubleshoot, you can fine-tune, and you can optimize before you go live. So our WAN emulators have over 26 different network impairments to offer. Some of the more recognizable are bandwidth restrictions, latency and jitter, packet loss, bit errors, congestion, and network outages. So this slide kind of speaks for itself. We've been in this market for a long time. We've done this before. Our product will save you money, time, but most importantly, it'll save you face. We have brand recognition and loyalty, and we are the leaders in the WAN emulation field. On average, Apposite customers save over $500,000 annually in remediation costs. So I think our numbers speak for ourselves. Okay, so I'm going to give you guys a quick demo. Let me get my screen shared here. In this demo, I'm going to show you a very simple website test using the Neotis NeoLoad product. If you're not familiar with Neotis, they're a leading performance testing platform. Their flagship product, NeoLoad, is an industry standard when it comes to load testing. They're also a partner of Apposite, so we highly suggest combining our services with theirs to get a total testing solution. In my lab here, I've created two different machines, both running NeoLoad. One is called Load Gen 1 and the other is called Load Gen 2.
Both of these are connected to the Apposite Netropy WAN emulator. And then the WAN emulator is connected to our internet gateway and then goes out to the web page I am testing, which happens to be called phptravels.net. So on the first Neo load, load Gen 1, I configured inside the Netropy to use a 5G network. This is 130 megabits upload, 130 megabits download, and anywhere from 20 to 40 milliseconds of delay. I got these numbers from Forbes Magazines when they recently did their 5G test using AT&T's network. On the second load generator, I have a very simple corporate WAN setting. If you see this, it has less throughput than the 5G network. So it's 100 megabits upload, 100 megabits download, anywhere from 15 milliseconds to 30 milliseconds round trip. So you kind of double these numbers to get a round trip. So that's how much latency you have. So on paper, this 5G network should outperform this corporate network because it has a higher bandwidth and the delay is not as much. So if you look at my lab right here, you can see that the 5G network will have some jitter anywhere between 40 and 60 milliseconds on its travel to PHP travels and back. And then the corporate network will have anywhere from 15 to 30 milliseconds to PHP travel and back. So I got this corporate network configuration from Spectrum's Bronze corporate offering. So if you order their Bronze service, it is 100 megabits up and down. And then I just did my own measurements to phptravels.net. So what I did is I ran these two tests, and within 5 minutes, I ramped it up to 40 users hitting phptravels.net. And then I compared both results. So I actually have the results here. I'll get into a little bit more of a live demo later. So if we look at the results here, this is the Neotsits dashboard screen captures, by the way. So the kind of important things you want to look at is the element. So we have the about the company, the blog, the visa form, and the homepage. By far, the most important thing is the homepage. So if we look at homepage and we come over here to what 90% of the users are experiencing is they are hitting an average of 2.2 or 2.3 seconds, right? So that's on the corporate WAN. Now, if we look at the 5G, what happens is we're now looking at 5.1 seconds. So for those of you who don't know, Google suggests never having a website over 5 seconds. So if I were a developer and I was doing my tests, maybe I just created my website up in AWS or rackchat.net or something like that, and I started doing my tests from my corporate WAN, I'd be like, oh, great, things are great. I'm less than 3 seconds. I'm less than 2.5 seconds. This fits with what is recommended by Google. But if you would have done the test using a 5G emulator or using one of our emulators configured for 5G, you would then see, wait a second, my homepage is taking too long to load. It's over 5 seconds. According to Google, this is substandard. So let's come down and look at some of our transaction times here. This is kind of just going over what we saw here. You can see here on the corporate WAN, we're averaging at 2 seconds. And you can see these little step up. This is us getting up to 40 users over the corporate LAN, hitting the phptravels.net website. And we can see we're not overloading the website. It's handling the traffic just fine. That's on the corporate LAN. So we can do the same on the 5G test as well, we can see we get up to 40 users, and it's staying the same, you know, around 5 seconds. So again, 5 seconds is not recommended by Google, so you would want to do something to increase the performance of this homepage. This is just the homepage. So, you know, maybe they would do some minification, some compression, take out some images, tighten up some code to get that below 5 seconds on the visits over 5G networks. So if we come down here, here's a quick little synopsis between the two. You can see here the home page is, you know, 2.3 seconds, and the 5G homepage loading is 5.1. That's 125% increase on the homepage. Most CTOs are going to tell you that's not acceptable. And we've seen out in the field that people do make this mistake. They assume that since it's working well in the lab, it's going to work really good out in the field, but they don't take account for, oh, even if you're on a 5G, it's not going to be acceptable. Now, what happens if we get on 4G or, you know, a 3G network? It's going to look even worse. So if I were a CTO and I had a programmer come to me and tell me, oh, okay, we're done, let's run some tests, and I'm seeing these 5G and 4G numbers up at 5, 6, 7, 8 seconds, I tell them it's unacceptable and they would need to fix that. So now I want to kind of jump into a live demo. This is what our Netropy product looks like. As you see here, I have load generator 1 and load generator 2, and load generator 1 is going through a 5G network, and load generator 2 is going through a corporate WAN network, and then they were both going to the PHP travels. So just for fun, I'm just going to show you how quickly and easily we can create these different types of networks and quickly test to them. Oops, let's go over here. And I'm just going to delete this endpoint. Okay, great. So right now we have load generator 1 assigned to 5G network and load generator 2 assigned to corporate WAN. Now, what if I would like to move load generator over to a different type of network? Maybe we have a 4G network. So I'll just create 4G LTE. And we actually have some quick drop downs that we can use here. Some presets, as you see, there's a bunch of them. We have a cellular Wi-Fi satellite, AWS. I don't know why this is called cable. I like to call it telco because it's old VDSL T1, T3s. And then we have some SD-WAN settings. So I'm just going to go to 4G LTE and I'm going to create that. And we can now see 4G LTE has 15 megabit download, 12.5 megabit upload, and a ping time of 50 milliseconds. So what I'm going to do here is I'm just going to quickly run a ping. So remember, going back to this, I'm on load generator 1. I'm just going to ping my gateway right here through the Netropy, just so you can get an idea. So where to go? Ping 192.168.168.1. I do believe that's my gateway. So as we see here, I'm getting 30 milliseconds, between 30 and 20 milliseconds of jitter. That's because emulation is turned on. If I turn it off, we now see the ping time go down to 0. So now I want to test over this 4G network. So I'm simply going to assign load generator 1 to this 4G LTE. So I'll edit the load gen 1. I can see here he's assigned to the 5G network. I'm just going to go to 4G. I'm going to apply my change. And now I see load generator 1 is now on 4G LTE. We still see 0 ping time down here because I haven't turned on emulation. So I'm going to quickly turn on emulation, and we should see our 50 millisecond ping time, which we do, right? And maybe we want to make some changes on the fly here. Maybe we have a situation where it's a UDP product and we might see lots of duplicate packets. you know, a 70% chance, this is unrealistic, ladies and gentlemen, but a 70% chance of duplicate packets. So I'll apply here, and now we start seeing duplicate packets down there. Great. Go ahead and turn this off again. Apply, and then we'll see the duplicate packets disappear. And so maybe I just want to even do some other tests as well. I can create something like a satellite connection, and I always like using satellite because it's such an extreme ping time. We can see here we're going to have anywhere between 900 and 2 seconds of delay, and a 5 megabit download or 3 megabit upload. So right now we're still on 4G LTE. Maybe I want my load generator to now test over satellite connection for some reason. And the reason why I'm going to such extremes is, you know, you don't have to be confined to just Wi-Fi services. I can also do T1s, and this doesn't have to emulate cell phone. We can emulate SD-WANs. We can emulate a terrestrial line over the Pacific Ocean, maybe San Francisco to Tokyo or something like that. I just happen to be using a lot of wireless examples here. So I'm going to choose the SATCOM. I'm going to apply this change, and now let's take a look at our ping time down here. Oop, there's 1 second, 1.1 second, 1.7 seconds. Now we're getting a lot of jitter, right? So this would be like testing the load generator over a satellite link to the destination. So I just wanted to show you how quickly you can move your test around to different types of networks and how quickly you can create your own networks. So I'll create a couple more just to show you how easy. Maybe you want to test over an old T1 line, which is 1.5 megabits in both directions. Now I have a T1. All right, so maybe you have an SD-WAN connection that you want to test over. So we'll do an SD-WAN bad, I'll create that. And we can see that we have a 400 megabit line with anywhere from 50 to 80 millisecond round trip time. And I can move these around all over the place, and I can have multiple endpoints as well. So I'm going to turn off my emulation. We'll now see my latency go back down to 0. Great. So that's the Netropy in a nutshell and also how using a WAN emulator you can test with realistic environments.
So at this time, we're going to open it up for questions. If you have any questions, you can type it in the Q&A box.
There's some questions in the chat.
Yeah, I was going to say, it looks like one of the questions is, how would changing from UDP to TCP reduce latency?
Changing from UDP to TCP does not reduce latency. It actually reduces loss. If you're familiar with UDP protocol, I like to call it fire and forget. It sends the packet to the destination and never worries about receiving acknowledgement. So you don't know how much of your data got lost. Whereas with TCP, if you don't get an acknowledgement, you'll resend the packet again and you have acknowledgements.
Okay, we have another question. Does the Netropy generate its own traffic?
The Netropy WAN emulator is not a traffic generating tool that's specifically designed for creating networks to test over. We do have an option within our device that I like to call, it creates argumentative traffic contained within our box. So what it does is it creates interference traffic and it stays contained within our box, but it doesn't generate actual data to flow through. We do have another product called the traffic generator, that does do that. It does generate traffic. If you're interested in that, maybe we'll do a seminar on that as well.
Another question, what sort of changes can developers make to their applications to make them more resilient to dirty networks? Can you share any real customer examples?
I think Scott's probably the better one for that one.
Well, there's a couple of things you can do, and they're pretty common sense things. I would analyze the traffic that's being passed across the network and find out, do we have to make as many calls? Sometimes we find that we're making so many calls and we're putting too much data in each call. We need to back off. Maybe we just need to send smaller pieces of JSON instead of some bigger record. But accounting for that is the biggest thing. But some developers don't even know how many calls are actually being made because they're not looking at things like APM solutions and things that would analyze, or even network analyzers that would look at that. So the amount of talking that's being done back and forth, do you have to make every one of those calls? Are you making redundant calls? Are there things that you can strip out that you don't need to be making a call for? I actually just tested a mobile application that actually did that. They were calling something, and then the next step down, they were calling that same thing again when they had already called it. And they were like, why are we even doing that? But I had to break it down at an API level for them to see how many times they were actually calling it. So just by reducing that, they cut the number of calls in half and the data in half. And then reducing it, compression, anything they can do to reduce that is going to help you. So those are some ideas. Moving to, in some cases, HTTP2, putting a proxy in front of your website just to get compression on the headers will actually help as well. So there's, I guess, 3 things.
Thanks, Scott. Can your WAN emulators be used to test IoT devices or platforms?
Absolutely. We have plenty of customers out there that are IoT customers. Some of the more famous ones are doorbells that are connected to your Wi-Fi and call your cell phone when someone rings them. We have other customers out there that are set-top boxes that are IoT. There's appliance manufacturers out there that, TVs, everything. You can test IoT over us, and we can actually create a shared link environment. So if you want to create an entire house that has multiple IoT, so if you look at Neotis, they have a specialized neoload test that says, okay, we'll create a house that has 5 or 6 IoT devices and then do a load test using that. So if you incorporate Neotis and us, you can get really accurate results.
Okay, we have a specific question here. Carlos would like to emulate a multi-point to multipoint WAN that has multiple hops and mediums. Is Netry able to emulate a complex multi-point system like this virtually and connect to a physical server or virtual machine?
Yeah, so what we do in scenarios like that, and we have SD-WAN customers and even switch and router customers who do this. So rather than creating multiple hops, we do the entire round trip. So if you had a hop that the first hop is 50 milliseconds, the next hop is 25 milliseconds, and then the third hop is 20 milliseconds, rather than trying to create those 3 different circuits that add up to 100 milliseconds, we just create that circuit to be 100 milliseconds and then add the impairments that are needed if it's loss or jitter or network outages or whatever it may be. So we have many SD-WAN customers out there that use us. Some have gotten very creative with their routing to create the multiple hop system exactly as you're talking about, but the majority of people just use the entire round trip numbers to do their testing.
Great. And is this WAN emulator available as a software?
So we do offer it in VMware, Docker, the cloud. So those are considered software, but we still run as an appliance within those environments. So even in Docker, you're still going to run as like a layer 2 bridge or a layer 3 bridge. So you can use us in software, VMware, KVM, OpenStack, AWS, Oracle, Azure, Google. We run in all of those as well.
All right, it looks like that was our last question. Give you guys a moment if there's any more.
Did you see the top one there, Rebecca, that about 5G? I don't have any information on it, but maybe Kate does.
Oh, do we have any updates on data sheets and documentation about 4G and 5G?
So for this demo, I actually used Forbes Magazine's numbers and everything on 5G. When I was doing my investigation, I was getting all sorts of different information about, oh, you're going to get 1.5 gigabits and this and that. But I went with Forbes Magazine because they were the only ones who actually did live 5G tests on a real 5G network, not some of these kind of, I hate to call them fake 5G networks that we're seeing right now. But they actually did real 5G tests, and that's where I got those numbers from, was the Forbes Magazine. There are some other websites out there that are doing testing. They're just slipping my mind at the moment. We can send out the information once my mind starts working again. I think it's like networkreports.com or something like that, but I'll look it up and get it out to people.
All right, and do you have an API that can be managed via CLI to make dynamic tests?
Oh, yeah, great question. Everything you saw in my demo is completely automatable using our RESTful API. It uses, as I said, RESTful API and JSON. There is not a command in the GUI that cannot also be executed in our API. And if you're interested in that, I can offer up some Python or some Bash scripts on some configurations if you want to take a look at it.
Okay, well, that'll wrap it up. Thank you guys, everyone. If you have any further questions that we weren't able to address, feel free to reach out to the emails on your screen. All registrants will receive a copy of the webinar recording as well as the presentation slides in the coming days. Thank you again, Cade and Scott, for your time today.
Thank you.
Thanks, Becca.